In this video for section 1.7, apply estimation strategies and rounding rules to real-world problems, the first thing we need to do is we need to look and find our objectives for this particular section. We're going to estimate metric measurements. We're going to know when it is appropriate to use a given estimation or rounding procedure. We're going to know our rounding rules for both decimals and fractions. And we're going to demonstrate knowledge of estimation strategies. We're going to use in a simpler problem. We also need to know our key terms. Estimation, metric system, and rounding are our three key words for this particular section, so make sure you're familiar with them. We're going to discuss each one of these in a little bit more in depth throughout this video. One of the first things you want to do is, first you must have knowledge of some simple approximations for common metric units. We're going to be using these metric units later on in another section, but I want you to become at least a little bit familiar with them right now. I'm going to give you a little bit more information about each one of these measurements to make it easier for you to understand based on what, since you're using the U.S. system of measurements right now. 1 millimeter is about the thickness of a dime. That's also about 3/64 of an inch. A centimeter is about 25/64 of an inch, and it's also about the average width of your pinky fingernail. 1 meter is about 39 inches in length, so it's a little more than 1 yard, which is 36 inches. A kilometer, or kilometers, however you want to pronounce that, is about 2/3 of a mile. It's also the average adult walks 1 kilometer in about 15 minutes. Some will go faster, some will go slower, so just know that a kilometer is about 2/3 of a mile. 1 gram is the weight of 1 aspirin tablet, and later on you're going to learn that 28.35 grams is equal to 1 ounce. 1 kilogram, is about 2.2 pounds. So a 5-pound bag of sugar weighs just over 2 kilograms. And Celsius is the metric unit of temperature scale. Where the U.S. has the Fahrenheit, the metric is Celsius. And in Celsius, 0 is freezing. And later on you're going to learn that the boiling point of water is 100 degrees Celsius. One of the other units of measure I want you to know is down here at the very bottom, the last sentence. That 1 cc, or cubic centimeter, is the same as 1 milliliter. This is a measurement that a lot of medical people have to know. Another thing you might be familiar with is 2-liter bottles drinks. So 2 liters is about 2,000 milliliters, or 2,000 cubic centimeters, where 1 liter is equal to 1,000 milliliters, or 1,000 cc's. In this paragraph, it says that estimating and rounding are two skills that make many problems quicker and easier to solve. So I want you to read this whole paragraph here, and when you're estimating, you need to decide, how close do I need to be to the actual answer when I'm working a particular problem? Or can I just be in the ballpark and be reasonable? Sometimes the ballpark figure is reasonable and close enough. So when you're working a problem, you're just going to have to decide how close do you want to be in your answer. There are two ways we're going to round. The first way we're going to round is to learn how to do it with decimals. As you can see, the decimal place you need to round to depends on the problem you're working on. So sometimes you're going to be round to the ones, the tens, the hundreds, the thousands, hundreds. Any decimal place value you can round to. You just have to know what the rule is. So when rounding to a decimal place, such as the tenths or the hundredths place, look only at the digit immediately to the right of the place to which you're rounding. And the rule says, if that number is 5 or larger, round up. If it's less than 5, just drop the digits that follow and do not put zeros in there, because some systems or some tests may put down an extra 0 as being a wrong answer. So don't put a 0 unless it's absolutely necessary. So we're going to study this table right here. In this first example, we want to round to this place, which is the ones. So the first thing we need to do is find the ones place in our decimal number. Well, the ones place is right here at this 7. So we have to look at the digit that's immediately to the right of that, which in our case is the tenths place on this side of the decimal. Well, this number is 3. So we go back up here and look at our rule. It's less than 5, so we're going to drop the digits that follow. That means anything after this 7, we're just going to drop it. So our final answer is just going to be the whole number, 57. In our second example, it's the same number, but this time we're going to round to the tens place. Well, the tens place is where the 5 is at. So we're going to look at the ones place, which is the place value immediately to the right of the tens. It is a 7. So our rule says for 5 or larger, round up. So we make the 7, round it up to a 6. And this will make this number 60. Then we're going to go to the next one. This one we want to the hundredths place. So we have to know where the hundredths place is. Well, the hundredths place is on the right of the decimal. It's the second place. So here's where we're going to round to. So we need to look at the thousandths place, which is the number immediately to the right. Well, this number is a 9, which is greater than 5. So we're going to add 1 to the hundredths place and make our final answer 57.37. Then we go down here and look at the next one. We want to round to the thousandths. Well, the thousandth is the third digit to the right of a decimal point, which is an 8. We got to look to the next one, which is the 10,000ths place. It's a 3. So the rule says if it's less than 5, we just drop everything. So we're going to drop the 3 and only have 0.498 as our final answer. The last one is also rounded to the hundredths place. Well, the hundredths place is a 9. We look at the next place. It's greater than 5, so we're going to round the 9 up. Well, when you round the 9 up, it makes that actually a 10, which in case adds 1 to the ones place. So our final answer is going to be 0.50. Now, in this particular case, we can leave that 0 there because it was rounded to the hundredths. So if we did a computer program and it had a 0 in the hundredths place, we're fine. You could also just leave 0.5, and that will be fine also in most systems. So there's a few examples of rounding for the decimals. Now let's go to a rule for rounding fractions. There's 2 ways you can do fractions. The first way is not mentioned in the book, and I don't really want to mention it because unless you have a calculator, you're not able to do this one. But if you have a calculator and are wanting to round a fraction, take the numerator and divide it by the denominator. So go 3 divided by 8 in the calculator, and you're going to get a decimal number. Then you can apply the rules up here. So round to the ones place. In this particular example, if I did 3 divided by 8, when I did 3 divided by 8 on my calculator, I got 0.375. If I'm round to the ones place, I would have to look at the numbers in the tenths place, which is a 3. That's less than 5, so my final answer will be 0. But the way they want you to do it is not using a calculator. And there's a little trick to doing this. If you take the numerator, if it's greater than or equal to half of the denominator, then you round up. If the numerator is less than half the denominator, just round down. So let's take this example, 3 out of 8. Take half of 8. It is 4. Is the numerator greater than half of the denominator? Well, is 3 greater than 4? No. So we're going to round down to the next whole number. Well, since we didn't have a whole number, we're going to round down to 0. Let's look at 5 over 8. Take half of the denominator, so half of 8 is 4. Is 5 greater than 4? Yes. So we're going to round up to the next whole number, which in our case is just going to be 1. In this third example, we have 4 and 2 sevenths. We only need to look at the fractional part. So half of 7 is going to be 3.5. Is 2 greater than or equal to 3.5? No. So we're going to round down to the next whole number, which will be just 4. We're basically just throwing away the fraction because it's not greater than half of a whole number. Now 12 and 19/20ths, well, half of 20 is 10. Is 19 greater than 10? Yes. So we're going to add 1 to the whole number and become 13. Now 14 over 3 is really 4 2/3 if you change it to a mixed number. So to look at the fractional part, half of 3 is 1.5. Is 2 greater than 1.5? Yes. So we're going to round up to the next whole number, which would make the 4 become a 5. So rounding decimals and fractions to whole numbers, which are easier to calculate in your head or quickly with scratch paper, will enable you to estimate if your detailed calculations are reasonable. So here's 2 ways: rounding decimals and rounding fractions. And I've got a few more examples that are not in your book. You will see that these answers down here are your practice problems. I've also got these worked out in Canvas, so you can go back to the Canvas and review that section where you can see the practice problems worked out. Here are a few more examples of rounding decimals. 18.59, I want to round to the tenths place. So I want to round where the 5 is at. So I look at the digit to the right of that, which is 9. That's greater than 5, so I'm going to round up, and our final solution is going to be 18.6. And the next one, I want to round to the hundredths place. So the number in the hundredths place is the 2, but I got to look at the number next to it, which is an 8. This number is 8 is greater than or equal to 5, so I'm going to round up, and our final solution is going to be 29.43. Same number, this time I'm going to round to the tenths place. Well, the tenths place is the 4. So I have to look at the digit to the right of it, which is a 2. The 2 is less than 5, so I'm going to round down and just be 29.4 as my final answer. The next one is 18.948. We'll round to the ones place. So remember, the ones place is on this side of the decimal. It is an 8, but I still have to look at the one to the right of it, which is the tenths place. That's the number is a 9, so that's still greater than or equal to 5. So I'm going to round up, and my final solution is going to be 19, rounded to the ones place. So there's a few more examples of decimals. Now let's do some fraction ones. These are a little bit more difficult than the ones that was in the book, so we're just going to take them one at a time. 5/18, half of their denominator is going to be 9, so half of 18 is 9. We're going to look, is the numerator greater than or equal to half of the denominator? So our numerator was 5. That's less than 9, right? So the numerator is less than half of the denominator, so we're going to round down to the whole number of 0. Since we didn't have a whole number out here, we just automatically go to 0. That means this fraction 5/18 is not more than half, or not more than 0.5 if we change it to a decimal. Now 12/18, we're going to take half of the denominator again. That's still 9. Our rule says, is the numerator greater than or equal to half of the denominator? So our numerator is 12. Half of their denominator is 9. So in this particular case, 12 is greater than 9. So we're going to round up to the whole number of 1. And 13/26, take half of the denominator again. So half of 26 is 13. Is the numerator greater than or equal to half of the denominator? 13 is greater than or equal to 13. So they're equal in this particular case. So that would be like if you was doing a decimal, it'd come out to be exactly 0.5 or 0.5. So we're going to round up to the whole number of 1. So these are just a few more examples of how to round decimals and how to round fractions. If you have any questions on this section 1.7, make sure that you email me in Canvas, and I can answer any questions that you have.